Good morning, friends. Let's continue our discussion on RDD joins with right outer join today. In the previous two videos, we have already covered inner join and left outer join. So for the right outer join, we have to use a right outer join method here, which is a transformation method again, which will create a new Java pair RDD based on the left and right keys. So based on this, again, similar, the two test cases that we have written, test inner join and test left outer join, I created a similar one for test right outer join in Spark RDD. To save some time, I will just copy this code and then I will make some small changes on it because it's very much similar to left outer join. The only difference is that in the left outer join, we have to take, so we have got, in the left, we have got customers with all the customer ID and the customer names. And in the builds, which is the second Java pair RDD, we will having the customer ID associated with the bills associated. Okay, so for the right outer join, it would be, we will take all the customer ID, all the bills associated with each of the customer IDs. We'll choose for all of them, and then we'll try to pair them with the customers. Whatever customers are not present, for example, say 8, customer ID 8, which is present in bills, is not present in customers here because we haven't listed at who is customer ID with 8. So that's why for that it would be optional. It would be optional name. It would be nothing there. It will be optional.empty. Similar with left outer join that we did in the previous video. Okay, so let's put it into action. As mentioned, that I will just use right outer join here. Just change it to right outer join. Okay. And once I change it, I need to remove this first. And wait on. I'll just use right outer join here. Let me put it in the second line. Okay. So final. Okay. So as mentioned that after calling this right outer join, I will mark it as right outer join RDD instead. Okay. So we have got this RDD, which is a Java pair RDD, in which the customer ID, which is common key for both customer pairs and bills pairs, it would be having customer ID as integer. And as mentioned that because it's a right outer join, it will be containing all the pairs from bills pair. That's why the double would be, the bills will always be there. But for all the bills, we don't have all the customers, right? So that's why the first key would be, the customer name would be optional here. Because in most of the cases, except Mary and David, as we have learned, except two customer names, Mary and David, all the other customers would be empty here in this case because we don't have the customer ID for that. Okay, so let me copy this and I will do here and then Alt J and then use it to map it here. Okay, and now first of all, the same thing, I will print everything which is present in right outer join. And now here I will make some changes because now we don't have this optional key as the second parameter, but the first key. So I'll just change it here as 1, which is our optional. And now it should remove that compilation error. And it should be again that I should be using .get here instead. And here it should be nothing. It should, because the bill is there. Only the first parameter, the customer name, is optional here. That's why I'm using get. So whatever our match, whatever the customer, I think we already tested as Mary and David would be the only customers having the bills there. So here it will print Mary and customer, but for all of them others, for all the others, it would be nothing there. So I can change this parameter, right? Because we don't have any order. We don't know which customer has placed that order, so right. So that's why I make some small changes in the things here. So it's not %s, but it's %2. Okay, let me change it completely to make it simple. So what I will do is that do not know who placed the order of whatever the bill that we have, and I will mark it as only like 2 decimal places, % or 2. I always use, guys, I've told many times that I use printf whenever we have a lot of string like interpolation here in between. If we use string paren, and we use like plus operator, then it will result in a lot of string concatenations, and that which is not very performance efficient. Using printf is better in this case when we have got to lot of embed, lot of strings, lot of variables in between here. That's why I use printf. Okay, so let's revise what we have done so far. It's very much similar to leftOuterJoin as we discussed, and we just got rightOuterJoin method from customer pairs to bills pairs, and we expect that only we will be first of all getting all the bills which are there in the bills pair. That's why the second tuple is having double, not as an optional right now, because it would be printing all the bills there. And because for all the bills, we don't have the corresponding customer ID in customer pairs. Only 2 customers are having there. Rest all the customers are not present, which are present in bills pair. That's why the customer name would be coming as optional here. So in the previous case, leftOuterJoin, because we were taking care of all the customers, that's why we were sure that the customer names will always be there, or whatever present in customer pairs. And because all the customers are not present in the bills pair, that's why the second field, the bill, was optional here. And for the rightOuterJoin, it's just opposite of that. So it's just like we don't have the customers. And then we again print out whatever is there in the rightOuterJoin RDD. So we expect a lot of optional.empty for a lot of bills associated. And then we just simply print that for the 2 customers which is present, it should be printing that the number of orders, the total bill of the orders that has been placed. And whatever customer IDs are not present, we'll just print that if we don't know that who placed the order. So let's run this now and see whether our expectation is correct. So it's running now. Almost. Okay, so it has completed now. So, okay, let's look at this. Because it's a full rightOuterJoin, so let's go back to the bills and customers. Okay, so for bill 150.5, as we can see that there's no associated customer ID. Customer ID 8 is not present here. That's why it's printed as optional.empty. Similarly for 9, only we know that for 5 and I think 5 and 2, which is David and Mary, only these 2 customers have got a corresponding bill associated in the customers pair. That's why only these 2 are printed here. The rest, all of them with customer ID which is not present, is printed as optional.empty. And as our second statement, as we have put that only for 2 times it would be printing the customer name with an other. For other, it would be do not know who placed the order for this. Only David had order of this and Mary had order of $199.90. So guys, this was about rightOuterJoin, and it's again very simple. It's very similar to what we do in SQL. So it's not, nothing different than what in RDD as well. So now let's continue our discussion. I think we have covered inner joins, and inner join is a default when we call this join. Then we have covered leftOuterJoin in the previous video. In this video, we covered rightOuterJoin. In the next video, we'll cover fullOuterJoin, and finally, we'll conclude with Cartesian products. See you all on the next video, where we'll cover fullOuterJoins.